Okay guys, today we're going to be talking about precipitation reactions. Now, on Schoology, there's a file above this that has some notes. They look like this. And then it has some notes taken on solubility rules that look like this. If you have not yet copied down those notes, please do so. Pause the video now, go take those notes, and then come back. If you have those notes, let's talk about precipitation reactions. So precipitation reactions always start out with two aqueous ionic compounds, okay? So I have two things dissolved in water. Now this is important because ionic compounds, when they're dissolved in water, actually break apart into ions. So instead of having barium nitrate floating around, I'm gonna have Ba and NO3. Now these are ions, so it's important that I know their charge. So if I look, Ba has a charge of +2. NO3 has a charge of -1. Now the same thing happens to sulfuric acid. He's going to break apart into hydrogen and sulfate. Now sulfate keeps that little subscript of 4 because he's a polyatomic ion. Hydrogen is not a polyatomic ion, so I ignore this 2 for now. The 2 was only up here to balance charges. H had a charge of +1. SO4 had a charge of -2. So I needed that 2 here to cancel those out. Okay, so step 1, I break my ionic compounds into ions. Now precipitation reactions are also called double replacement reactions. Two things trade partners. Now when they trade partners, it's important that I keep something positive partnered up with something negative. I can't have 2 pluses together. I can't have 2 minuses together. I have to have a plus with a minus. Now, because these are forming ionic compounds, I need to check the charges. Ba is a +2, SO4 is a -2, 2 and 2, they squish together. They cancel out. H is a +1, NO3 is a -1, 1 and 1, they cancel out, they squish together. Okay? Now, just like with single replacement reactions, I need to make sure that everybody's happy and balanced. 1 Ba on the left, 1 Ba on the right. They're good. 2 NO3s on the left. Whoops, only 1 on the right. So I need to multiply him by 2. That fixes my NO3s. It also changes my H to 2. But I had 2 of those to start with, so that's okay. 1 SO4, 1 SO4, so I'm balanced. Now for precipitation reactions, the states of matter are super important because the way I know that a precipitation reaction happened is I start with 2 aqueous compounds and one of them needs to form a solid. So I'm going to be using my solubility rules to figure out which one is the solid. I'm always looking at the negative ion. So SO4 is going to be soluble in water. He can dissolve, so he's aqueous. Unless if SO4 is partnered up with SR, BA, HG, or PB, then he's a solid. Well, in this case, SO4 is partnered up with BA. BA SO4 is going to be solid. NO3, if I look, is soluble. He dissolves in water. He's aqueous. There are no exceptions. He is always aqueous. Do not forget states of matter. Those are super important on precipitation reactions. Okay, let's take a look at number 2. NiCl breaks into Ni and Cl. I ignore the 2 for now. That 2 is a part to balance charges. So I look here. Uh-oh. Nickel can be either a 2 or a 3. Well, the way I figure out which one he is now that 2 is important. I know that when charges don't cancel out, I had to switch them. Chlorine is a -1. I had 2 of them, so nickel has to be a +2. AgNO3 is going to break into Ag and NO3. Ag has a charge of +1. NO3 has a charge of -1. So everybody's dissolved in water, everybody's aqueous, so they break apart into ions. I switch partners, positive to negative, positive to negative. When they switch, I have to keep track of charges. +2, -1. This time, they don't cancel out. So when they don't cancel out, I have to switch. This 1 comes over here. This 2 comes over here. So I have Ni1, NO3, parentheses, he's a polyatomic ion, 2. Ag is a +1, Cl is a -1, 1 and 1, they're fine. I stick them together. Just like with single replacement reactions, I need to make sure everybody's happy and balanced. 1 Ni, 1 Ni, 2 Cls, whoops, only 1 Cl, 2 in front. That fixes my Cl. It also changed Ag, 2 Ags, 2 Ags. Whoops, that also changes NO3 to 2. But I needed that, so it's okay. So the last thing I need to do is it's a precipitation reaction. One of these is a solid. So I need to check and see which one it is. Okay. So I look at the negative ions. NO3 is going to be soluble. He dissolves in water, so he is aqueous. There are never any exceptions. He is never a solid. AgCl. Cl can normally dissolve in water as well and be aqueous, unless he's partnered with Ag, Hg, or Pb. Well, in this case, he's with AG. Because he's with AG, he's going to be solid. Okay. Now, I want to look at one last one really quick. Down here, NaOH and FeCl3. If we break them up, Cl is the same as Ni was. If I look, sorry, not Cl, Fe can be either a 3 or a 2. He can form multiple charges. So just like I did up here, I have to look at who he's partnered up with. Cl is a -1, and I needed 3 of them. So if I've got 3 negatives, I have to have 3 positives. Okay? So if you have elements where you're unsure of the charge, things like Cu, Ni, Pb, I lied, Pb's over here. But if you don't know the charge, you need to make sure that you're looking at who he partners up with, okay? Little numbers balance charges. Big numbers are the last thing I do. I put them up front when the little numbers, the subscripts, do not match, okay?